All right, rational exponents and radical functions. So the first thing we need to do in order to deal with rational exponents, radical functions, is understand what the nth root of a looks like. So what you're familiar with in the past mostly are square roots. So like say I have a square root of 2. Okay, actually let's use a number other than 2, like say maybe the square root of 3. Okay, so square root of 3. Really, when we say square root, we're actually saying the second root, and we don't show that usually. It's saying what number times itself twice, this many times, makes that number. Okay? So like if we had the square root of 4, what number times itself twice makes that number? Or the square root of 9, what number times itself twice makes that number? Or the square root of 16, what number times itself twice makes 16? And you know that is 4. Okay? So we don't show that 2 usually. Okay? So if we go, say, into the cubed root, well, the cubed root of, let's say, well, we'll use 16. The cubed root of 16 says what number times itself 3 times? Okay, so what number times itself 3 times makes 16. All right, that's what cubed root means. And we can rewrite the cubed root of 16 as 16 to the 1/3 power. And that's what this is saying. The nth root of a can be written as a to the 1/nth power, just like so. Okay, so if you're using a calculator, you can put the 1/3, 16 to a 1/3, and find a solution, and the cube root of 16 and find the solution. They'd be the exact same value. Okay, so that's what the nth root means there. So if I'm trying to deal with some of these and find the indicated real nth root of a, really, I'm saying, okay, I want the nth root of a. I can take, in this case, the nth root, or the 5th root of negative 243. And I'm saying what number times itself 5 times? 1, 2, 3, 4, and 5. Okay, what thing times itself 5 times makes 243? That's what we're looking for. Okay? Well, that might be a little tough if you're not familiar with your 5th root. So one thing that might be helpful to you is at the start, just make a quick table where x is 1, 2, 3, 4, and 5. And then go ahead and put in x squareds. Okay, so like, and x cubes. Okay, and you need to go, go out all the way out to x to the 5th. Okay? So really that's saying we're going to go ahead and square 1, and then square 2, and square 3. Okay, oops, that's not 2 squared. Okay, 2 squared is 4, and 3 squared is 9, and 4 squared is 16, and 5 squared is 25. It's really easier if you move to from left to right, though. So 1 times 1 is 1, times another 1 is 1, times another 1 is 1, times another 1 is 1. In fact, 1 to any power is 1. Okay? Well, 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. That means 2 to the 5th power is 32. 3 times 3 is 9, times another 3 is 27, times another 3 is 81, times another 3 is 243. Okay? 4 times 4 is 16, times another 4 is 64, times another 4 is 256, times another 4, well, 4 times 250 is 1,000, and 4 times 6 is 24, so 1,024. 5 times 5 is 25, times another 5 is 125, times another 5, 625, times another 5, well, 5 times 600 is 3,000, 5 times 25 is 125, so that's 3,125. All right, so using that, I was trying to find the 5th root of 243. Well, 5th root, 243 is 3. All right, so I'm going to go back here. This is equal to 3. Well, we'll notice something interesting. There's a negative in there. So what you need to ask yourself is negative 3 times negative 3 times negative 3 times negative 3 times negative 3 make negative 243. Negative, negative is positive, times negative is negative, times negative is positive. So notice pairs of negatives make a positive. But then you have that extra negative without a pair there. So that means my answer is negative. So yes, it's negative 3 there. All right. So if I was taking just the fifth root of regular 243, that would just be positive 3. All right. Or the fifth root of 0. So what number times, so 5 times makes 0? Well, it's 0. In fact, any root of 0 is 0. All right, let's move over to this side and we'll come back and answer the question about the real type of roots. Let's say I have the fourth root. So I'm going to do the fourth root of 625. Okay? Well, note that I could have also written that as 625 to the 1/4 power. Okay? In fact, I could have done that on all these. I mean, I could have wrote this as negative 243 in parentheses to the 1/5 power. Or 243 to the 1/5 power. Or on this one, 0 to the 1/5 power. Okay. Well, 625, the number that multiplies by itself 4 times to make 625 is 5. However, notice we talked about negatives over here, and remember pairs of negatives make positive. So notice that 1, 2, 3, 4 negatives made a positive. So what if I did negative 5 times negative 5 times negative 5 times negative 5? Well, notice those pair make a positive. That pair makes a positive. So I have positive and positive. That is positive. So that means positive 5 works, but also negative 5 times itself 4 times works. So anytime you write a problem out in either radical form or exponential form with a denominator there, then you always have to assume if it's an even power that it's positive and negative. They want the positive and negative answer. Now, I will tell you, if many times in math, if you're working out problems and they're already given to you, say like, let me switch the page real quick. I think I have one on the next part. Let's move on here. So like say this one right here, I'm taking the square root of 4. Okay. This right here, when it's already written out, that means they just want the positive root. Okay. So if it's already written out for you, you don't have to assume the plus and minus. Whereas if it's not written out for you, like it wasn't written out for us right here, we had to write out, so we have to put positive and negative out in front because we don't know what they're actually asking for, the positive or the negative value. Okay, well, let's go ahead and do the fourth root of negative 625. Or another way to think about it is negative 625 to the 1/4 power. So what number times itself 4 times makes negative 625? Well, to get a negative, you have to multiply by a negative. And if one's negative, they're all going to be negative. And we know that 2 pairs of negatives make a positive. Therefore, this isn't good. There's no way to multiply 4 things together, 4 of the same thing together, to get a negative. So this actually is a no real solution. All right. This last one is the fourth root of 0. Remember, that's the same thing as 0 to the 1/4 power, and any 0 to any power, or the root of any root of 0 is 0. Okay, so looking at this, roots with an odd index, a 5, a 3, a 7, a 9, okay, are going to have one real solution. Whereas roots with an even index, 2, 4, 6, 8, 10, roots with an even index could have up to, well, notice we had 1, we had none, we had 2. We could have up to 2 real solutions, or real roots. Some info for us there. Okay, let's try another problem. Actually, let's try a different concept here. When, or continue with the same one, I guess. When a to the 1/n power is raised to the power of m, we end up with a to the 1/n all to the mth power. And really, that's written out like this. Okay, if we change the form of a to the 1/n, the root of a, or the nth root of a. And we put that in there. That. Another way to think about it, and this is the way our textbook likes to think about it. Another way to think about it is like so. Okay, we have a to the 1 over n to the m, and then we distribute that m. We use power, our properties of power, so properties of exponents there. So that gives us a to the m over n. And whenever you have a to the m over n, this denominator is your root, just like we talked about. But if you have a numerator, that numerator is actually your power on the inside. Okay? So let's give an example. That's easier to see with numbers. 8 to the 2/3 power. Well, the 3 is your index, your root there. The 2 is what we're raising 8 to. And you could also think of it like this, like our book likes to. So that would be 3 and then 8, and you could put the 2 out here. In fact, it's a lot easier sometimes to think of it like this because the cubed root of 8 is pretty easy. It's 2. And then we square that 2 to get a 4. It's a little more difficult to go in the opposite order, and you can do it in either way. You can square first and then cube root, or cube root and then square. So if I take the cube, or if I take and square it first, I get the cubed root of 64. So now I have this bigger number to deal with. The cubed root of 64 is 4. Okay, it's just a bigger number that you're dealing with here rather than that 8. So either way works. I like to use this method, but you'll also see it like so. Okay, so let's try some of these. Okay, we actually just did this one, 8 to the 2/3 power. Well, that is the cubed root of 8 and squared. Cubed root of 8 is 2, and then 2 squared is 4. All right, so remember when you have negative exponents, in fact, let's review that real quick. If I had a to the negative n, remember, a negative exponent just means I put it under 1. Okay, or better yet, let's think of it this way. I write my problem in fraction form, and I take and I move the thing being raised to a negative to the other side of the fraction. So that's going to be a to the n. When I move it, the negative disappears. It's 1 over a to the n. So when I'm dealing with 81 to the negative 3/4, really, that means that I need to go and write this as a fraction, and the base that's being raised to a negative changes sides. So I now have 1 over 81, and the 3/4 now is positive. And then let's go ahead and write that as 1 over the 4th root of 81 cubed. Okay, well, the 4th root of 81 is 3. And 3 to the 3rd power is 27. So this becomes a solution of, I'm kind of moving into the next problem, but it's 1 over 27. I'll kind of box this off here. I'll switch colors, help us keep it clear. So that negative exponent, remember you got to switch that side. Okay, so this 4, we are taking the square root of 4 all to the 7th power. The square root of 4 is pretty easy, that's 2. And then we're going to raise that 2 to the 7th. Well, 2 to the 7th, count it on your fingers. 2, 4, 8, 16, 32, 64, 128. It is 128. Another thing to think about, anytime you have a power that you can reduce, like 4/2 reduces to 2, go ahead and do that. So this actually equals 8 squared, which is really easy at 64. It's much more difficult if you don't reduce it first. And the last one, 1 to the 9/10. Just remember, we're doing the 10th root of 1 all to the 9th. And 1 to any root is 1. And then when we raise that to the 9th, that's still 1. So really, 1 to any power is 1. So that's 1. Okay, evaluate each expression using a calculator. Round your answer to the hundredths. Just a quick note on this. I'm not going to show how to use the calculator on the computer here. I'll kind of give some keystroke steps, but if you're struggling with your calculator use at all, you really need to talk to your teacher and find out where the different keys are. Okay, so, but 11 to the 4/9 power, I'll kind of point out some of the normal keys. You'll see, if you're using a graphing calculator, you want to locate the key that looks like this. It's called the caret symbol. So you're going to type in 11, caret, and then 4 divided by 9. Okay, and that will kick out an answer for you. When you hit enter, it'll give you 2.90 if we're rounding to the nearest hundredth there. Now, if you don't have a graphing calculator, you use a scientific calculator. Usually there's a button that says x to the y or y to the x power where you have to enter it. But I would suggest you bring it up to your teacher and have them help you out then. Okay. So this one I put in 7, caret, and then depending on the operating system you have, you may have to put parentheses. And you go -2 divided by 3. Okay. And you may have to put parentheses here as well. All right. And that would give you approximately 0.27. All right, if you want to use radical format like this, there is a button on the graphing calculator, the TI-84s. If you push math and then number 5, okay, math number 5, I believe it, let me double check on my calculator real quick here. Yeah, that's it looks like this. Okay, in your calculator. All right, so what you'd want to do when you actually push that, if you did that, it's going to probably give you something that looks like this on your screen, A and S, and then have a place for you to type here. And this is where the 21 goes, obviously, but the A and S needs to be a 3. So what you would want to do is you would on a backspace use your arrows to come over here and get rid of the A and S and type 3. Okay, or you could hit 3 and then this, and it would let you. Then you wouldn't have to do that. Then put in the parentheses and to the 4th. That actually give you approximately 9.81. All right. Hey, one last thing is just solving equations with nth roots. And really you're just doing these just like you would solve any other equation using inverse operations. Divide by 4 on both sides. X cubed is equal to 32. Or it's not 32, excuse me, 8. And then the opposite of cubing something is taking the cubed root. So I take the cubed root on this side, and whatever I do there, I have to do over here. Okay, I'm supposed to read the cubed root. Okay, and the cubed root, that gives me x. Cubed root of 8 is 2. And you can always test it. 2 cubed is 8 times 4 is 32. The difference becomes is when you have these even powers. So be careful with the even powers because the first step is to take the 6th root in this problem. And remember, when you impose an even root, you've put it in there. You've written it in that format, which means you're left with x minus 7 on this side, but over here you have a plus minus 6th root of 39. Don't forget about that plus minus. Add that to your notes. Okay? You've got that plus minus that you have to deal with. Okay, the next step would be to add 7 on both sides. And the way I'm going to write that, that's going to be 0. So I'm going to be x is equal to 7 plus minus 6th root of 39. Really, there's 2 problems that you have there. You have 7 plus the 6th root of 39 and 7 minus the 6th root of 39. And 7 plus the 6th root of 39 happens to give you 8.84 if we round it. So let's put an approximation there. And 7 minus the 6th root of 39 gives you approximately 5.16. So your solutions, x approximately 5.16 and 8.84. All right, so don't forget about that plus minus. I think that's all I got for you there. Good lucky.